Afternoon. My name is Navasya Nicole, and I'm representing Group 11, and I'm going to take you through. Slide 1, 2, and 3. So we're going to be presenting experimental research, a strong data collection technique, and I'm going to introduce the topic to you. So experimental research is a scientific method used to explore cause and effect relationships. In simple terms, it helps us understand how one thing affects another. In scientific research, and it allows researchers to establish cause and end effect relationships, and then control over variables leads to accurate and replicable results. So why are experiments a strong data collection technique? Establishes causality. So this means experiments help us determine if one variable causes a change in another. And then there's also high level of control, which means researchers can control the environment and other influencing factors so the results are more accurate. Then there's replicability, which ensures that experiments can be repeated to check if hold true over time, which improves reliability. Then there is quantitative precision. Participants can be placed in groups randomly, which helps eliminate bias and ensures fairness in comparisons. Then there's generalizability, whereby experimental results are based on measurable data and are less likely to be influenced by personal opinions or assumptions. I'd like to call my next colleague to present slides 4 and 5. Thank you so much.
Hey everyone, this is Kesani Aisha, and I'm going to explain the fundamental principles of experimental research. So I'm going to explain one by one. As you can see, we have manipulation, control, randomization, replication, and comparison. So in manipulation, this involves changing the independent variable to see how it affects the dependent variable. For example, you might increase light exposure to see how it affects sleep quality. So when I talk about control, researchers keep all other variables constant to avoid interference. So in this way, any change in results can be more confidently linked to the variable being tested. So when I talk about randomization, participants are assigned to groups randomly to reduce bias. This ensures that the groups are similar and that the results aren't influenced by external factors. So when I explain the replication, for the replication here, it involves repeating experiments to verify findings, whereby this builds confidence that whereby results are variable and reliable, so not just by chance. I can take you through the next slide, slide 5. Slide 5. The key steps in designing and conducting an experiment. First of all, the key steps, we have to define the research questions and hypotheses. And when conducting an experiment, you ask yourself, what do you want to find out? And you put a clear question that gives out experimental direction. When then another question is identify variables. Here, like you ask yourself, like, what do you want to find out? And that clear question gives you an experimental direction. And another thing you formulate, you select an experimental design, and After selecting the experimental design, this is between subjects, within subjects, and for factorial. So another thing is you do some sampling, like you bring out different tests when you're carrying up out an experiment, so that you see what tests very well. So afterwards, you can control for confounding variables. And here I mean, afterwards, you conduct the experiment and collect data. Then you analyze data using statistical methods and interpret results, whereby you draw conclusions after getting the results, then you report. Then while drawing the conclusions, based on the data, decide whether your hypothesis was supported and what the results mean. And then when you're analyzing your data, you use statistical methods to determine whether the results support your hypothesis. Then when I explain this one, conduct the experiment and collect data, here you carry out the procedures where you carefully recording the data. Thank you. I'm inviting the next presenter.
Hello, my name is Alvin Aaron Arinda, and I will be taking you through slides 6 and 7, and we'll be talking about commonly used equipment and software. And among the commonly used equipment and software in experimental research, we have laboratory equipment, which are the common things that I believe most of us have interfaced with, which include microscopes, spectrometers, centrifuges, among many other things, and different kinds of sensors, and many others that we might not explain here, either in a medical field or different kinds of fields, depending on the field that you're working with. These are just some few examples. And then the computing tools for computing data include Python, R, MATLAB for data analysis, and we have SPSS, SAS, and Excel for statistical analysis. We have Correlytics and Google Forms for surveys, getting information from the general public or from a selected group of people that you want to get information from. And then you have ePrime and PsychoPy for behavioral experiments. Next slide, please. And when we're ensuring validity and reliability, we look at internal validity. We look at internal validity, which basically controls extraneous variables using blinding techniques. And in external validity, we basically use representative samples, and we conduct real-world experiments. Now, in internal validity, we're basically looking at the extent to which the observed effects in an experiment can be attributed to the manipulation of an independent variable. So we are controlling extraneous variables using blinding techniques like I had spoken of. And then in external validity, we're basically looking at the extent to which the results of the study can be generalized. So we use representative samples, we conduct real-world experiments. Then when we look at things like reliability, we standardize procedures to ensure that what we're doing is actually reliable. We calibrate the instruments to ensure that they are doing what is actually required and they are not mismeasuring. We use test retest methods to ensure that, after testing a number of times, we are getting what is actually required, or the values that we're getting are actually consistent after a number of times of testing. Thank you. Let me invite the next speaker to take you through the next slides.
Good afternoon, guys. This is Teacher Anzi, Group 11, and I'm taking you through the statistical analysis experimental data. Basically, under statistical analysis, we have descriptive statistics, which highlights the importance of summarizing highlights the importance of summarizing your experimental data using descriptive statistics. An example of this, we shall have the mean, which is the average value of your data, providing a measure of central tendency. Another, we have inferential statistics. Inferential statistics introduces the use of inferential statistics to draw conclusion or make inference about a population based on your experimental sample data. The other we have here an example I shall give tests. These are used to compare means of two groups, determining if there is statistically significant difference between the two. Another we shall have avoiding bias as a statistical analysis method. Avoiding bias basically emphasizes critical need to minimize the bias in your experiment. And here we shall use methods like double-blind studies. This procedure, where neither the participants nor the researchers are interacting with them, nor which group the participants are assigned. Basically, it helps the experimenter's bias, the participant is biased. Another, we have pilot studies. Pilot studies, this involves conducting small-scale trials before the full experiment. It basically recommends conducting pilot studies as a crucial step before running a full-scale experiment. So another slide. So here we have the best practices for experimental research. And one of them is to follow a structured methodology. Basically, this methodology emphasizes the importance of having a well-defined systematic approach to conducting experimental research. Under the methodology here, we can clearly define the research question. We design the experiment with appropriate controls and variables. We develop a detailed protocol for data collection. We establish clear procedures for data analysis, then we document everything. Another practice, we can use appropriate statistical tools. Basically, the necessity of selecting and applying statistical methods is suitable for this type of data collected and the research question being addressed. And under appropriate statistical tools, we have choose the correct descriptive statistics, summarize the data. Also, we select the appropriate inferential statistics and then understand the assumption for the chosen statistical tests. The other is to maintain transparency in data collection. Basically, this underscores the importance of being open and clear about the data that was collected. And basically, this includes clearly describing the data collection procedures, documentation. Here we document any deviations from the planned protocol. We potentially make raw data available for scrutiny, depending on the ethical practical consideration. Here we can also encourage replication and peer review. Basically, this emphasizes two vital aspects of ensuring quality and validity of the experimental research. And this involves replication, encouraging other researchers to independently repeat the experiment to see if they obtain the similar results, and successful replication strengthens the confidence of the original findings. We also have peer review. Peer review basically involves submitting the research findings to experts in the field for critical evaluation before publication. With that, that's what I have for today. Let's call on another presenter.
Good evening. My name is Terry Brian, and I'm going through the conclusion. Yes, to begin with, We know that experimental research plays a vital role in advancing knowledge by allowing researchers to determine the different cause and effect relationships. Excuse me. Yes, the different cause and relationships through control testing and manipulation of variables. Yes, we also know that proper design, control, and statistical validation ensure reliability, and continuous improvement through replication strengthens findings. Yes, that's all I had to say. Thank you so much.